For joining me. This is section 4.4, solve linear equations in one variable. 4.4 is a really big section, so I've broken it into 4 different days. We have whole numbers today, and then we'll do fractions, decimals, and word problems, okay? So remember those cards that we had out in section 4.3? We'll be using those again today. So here is our first problem. I have 5x minus 1 equals 9. So remember, we want to get that x by itself. So try to figure out what operation would I do first and show me that card. Okay, so you see the x there. That 5 is attached to it. So if we were in the classroom, I would kind of just cover up that whole section. Let me see if I can figure out a way to do that. What if I went like this? So on the screen, I would cover it with my hand. So just pretend like that's not there because that's where the x is at, right? So what do I have left over? I have that minus 1. So what I'm going to want to do is the opposite. So opposite of subtract is to add. Whoops. We're going to add, and we want to get rid of that minus 1. So we're going to add a 1 to both sides. So now I have 5x equals 10. All right, what do I do next? Show me that card. I would divide, right? Because that's attached by multiplication. 5x is 5 times x. So I would divide. What do I want to divide by? Get that x by itself. I want to divide both sides by 5. There we go. 5's cancel out, so I have x equals 10 over 5 is 2. And remember, we can go back and check it. So 5, instead of the x, I'm going to write 2 minus 1. We're seeing, does that really equal the 9? So we have 10 minus 1. That's true. 9 equals 9. So number 2. For number 2, I have negative 2x plus 7 equals 23. Okay, so here's the x. And we want to figure out what are we going to do first. So just pretend like everything here with the x isn't here right now. Now what do we have left over is that plus 7. So how do I get rid of plus 7? I want to subtract it, right? So there's our x again. We have a plus 7, so we're going to subtract. Minus 7 from both sides, so now I have a negative 2x equals, what is that? Looks like 16. All right, what should I do next? That negative 2 is attached by multiplication, right? So I want to do the opposite. I want to divide. Divide both sides by that whole negative 2. And I get x equals negative 8. And let's check our work. We have negative 2. Instead of x, I'm going to put in negative 8. Plus 7, does that equal 23? So I have 16 plus 7. That is true. We did it right. Okay, number 3. For number 3, I have 2 minus x equals negative 9. So here's our x. What should we do first? I see this positive 2, so how are we going to get rid of that? We should subtract, right? We want to get it off of there. So I'm going to do a minus 2 from both sides. And here, a lot of people just write x, but don't forget to bring down that negative, okay? That negative stays with the x right now. So now I have negative 9 minus 2 is a negative 11. So I have negative x equals negative 11. So remember, you can think of this as a little 1, right? If that helps. What should I do? Show me your card. It's attached by multiplication, right? So I'm going to divide both sides by that -1, and I will get x equals 11. And to check it, I have 2 minus 11 equals -9. 2 minus 11 is -9, so it's good. Number 4, I have 5x plus 4 equals 3x plus 16. Okay, so on this one, there are quite a few different ways that you can start this. Okay, so some people might want to subtract 5x from both sides, which is fine. Some people might choose to subtract 4 from both sides first, that's fine. Or you could subtract the 3x, totally fine, or the 16. Every single one of these will work out. Okay, so what we want to do is our goal is just to get all the x's to one side and all of our whole numbers to the other. Okay, so it's totally up to you on how you would like to do this, but we know that we're going to subtract. So if you want to try a different way, you are welcome to do that. Typically what I do, this isn't required, I look at the highest value x, so that 5x is bigger than the 3x. So I know if I go ahead and subtract the 3x from both sides first, that I will have a positive 2x. If you did it the other way, you would have a negative x to worry about, a negative 2x, right? So, and then that would add a whole extra step, because then at the end you would have to divide by a negative. So mathematically it totally works out, but I just like to try to do as few steps as possible. So right now I have a 2x plus 4 equals 16. And here, some people get confused. They're like, oh, well, let's subtract the 16, get it over there too. You don't want to do that, okay? We want to get all of our x's on one side, all of our whole numbers on the other. So now, what should I do? Show me that card. I would subtract again, right? Because now I want to get that -4 to the other side. So I am left with 2x equals 12. And what should I do next? 2x, that's multiplication. I want to do the opposite. That is divide both sides by 2 for our final answer of x equals 6. And we can check it. Everywhere I see an x, I'm just going to put a 6. So 5 times 6 plus 4. 3 times 6 plus 16. We're trying to see if this works out. So we have 30 plus 4 and an 18 plus 16. And we get 34 equals 34. Okay, next, number 5. I have 10 of these for today. Okay, so number 5 is going to be a negative 6w minus 3 equals a 4w plus 17. Okay, so this one, I want you to actually try to just do this one totally on your own. Okay, so go ahead and hit pause, give it a try, come back when you're ready. The answer ends up being w equals -2. Okay, so go ahead and give this one a try, come back when you're ready. All right, so in this one, lots of different ways that you could go. Okay, so as long as you got that w equals -2, you're good. I'm just going to go with the way I typically see students do it in class. Is most students like to see that variable on the left side. So even though that's not my personal preference, I wouldn't do it that way. It does work out. And since most of my students like to do it that way, I will do the same. So I will subtract the 4w from both sides. And I will get -10w minus 3 equals 17. Trying to get that w by itself, so that means I have to add 3 to both sides. So I have a -10w equals 20. Get that variable by itself by dividing both sides by -10. and I get W equals -2. And then I'll let you just go ahead and check that on your own if you want to. Okay, number 6. We have 8 minus 2x minus 2 equals 3x plus x. What should I do first? The first thing I want to do, so the card you would show me, is the combine like terms. Okay, so on the left here we have an 8 and a -2, right? This 8 minus 2, let's combine that. So we have 6 minus 2x equals, we have a 3x and a 1x equals 4x. Okay, now we want to get all of our x's to one side, our whole numbers to the other. On the left, we have both. On the right, we just have the x. So what I would do is go ahead and move that 2x over. So how are we going to move that over? The card would be add. Okay, because we have that 6 over here already. If you move to the 6 first, then you'd have to move the 4x. It would be just a couple extra steps. If you're really set on doing that way, mathematically it's correct. But I like to not write quite as much if I don't have to. So I'm going to add 2x to both sides. So now over here I'm just left with 6 equals 4x and 2x. I get 6x. And I want to get that x by itself. So I will want to divide both sides by 6. And I get 1 equals x. Okay. Number 7. Let's do a -3 times the quantity x minus 4 equals 2x plus 2. Okay, so the first thing I want you to do is tell me, what would we do first? So find this card. I don't think we've used this card yet. I think it's the only card that we haven't used. We would distribute, right? So you're going to want to take that -3 and distribute it to the x and to the -4. Okay, so you go ahead and try that. Try to solve the entire problem. When you're all done, you should get that x equals 2. Okay, so hit pause, give it a try, come back when you're ready. All right, so distributed that -3 to get -3x plus 12. Wanted to get all my x's to one side, so I just chose to add 3x to both sides, and I was left with 12 equals 5x plus 2. Again, that step you could have gone 4 different ways, right? So just essentially what you did is you got all your variables on one side, their whole numbers on the other, and I ended up doing the 12 equals 5x plus 2, so I subtracted the 2 to get 10 equals 5x. Divide both sides by 5, and I got x equals 2. So hopefully you did too. All right, now I have 2 of them. Let's see. Yeah, now I have 2 of them. They're a little bit different. Okay, so something new that we haven't seen before. So number 8, this is something new. I have 3x plus 4x equals 7x. First thing I would do is combine like terms. So I have 7x equals 7x. Well, what do I do there? That just looks really weird, right? I mean, I guess you could try like divide by 7 or something. And then you get x equals x. What happens here is when we get something equals something and it's true, this is called the identity. Okay, so if you get something equals something, and that's true, so that it equals itself, that's its identity, your answer, what you would write here for your solution would be the set of all real numbers. Okay, this would be our answer, set of all real numbers. And if you're like me and you don't like to write a lot, there's a shortcut. Anytime you want to say the set of all real numbers, you can do a giant R like this, and then just add a second bar. And that, just by itself, that means a set of all real numbers. So if you come across that problem and you would like to use that big double R, you are welcome to do that. Or if you prefer to write out the words, that's cool too. All right, number 9 is also something new. For number 9, I have 3x plus 8x minus 7 equals 15x minus 3 minus 4x. Let's go and work through this one together. So let's start by combining like terms. So I have 3x and 8x, I get 11x minus that 7. Over here on the right, I have 15x minus 4x. That's an 11x. I still have that minus 3. And I like to get all my variables on one side. This is where it gets weird, right? Because I took away the 11x from both sides. Well, 11 minus 11, that just totally went away, right? So now I have a negative 7 equals a negative 3. So what is going on there? This is inconsistent. There's lots of different ways to write your answer for this one. So some people say inconsistent, which means that it's false because negative 7 does not equal negative 3. For your answer, you could either tell me empty set. That works. Or a lot of people just like to tell me no solution. So anytime you get that, you can just tell me empty set or no solution. I'm fine with either one. All right, number 10, this is our last one for today. I have 5 minus r plus an 8r equals 3r plus 1. Okay, so what should we do first? Let's go ahead and start by combining like terms. So I have the negative r plus that 8r, so I have 7r, right? Here they are. So I have 5 plus 7r equals 3r plus 1. Next, let's go ahead and I'm just going to subtract the 3r. Again, you can, lots of different options there. So right now I have a 5 plus 4r equals 1. And I want to go ahead and get that r by itself, so I'm going to subtract 5 from both sides. So I have 4r equals a negative 4. Then I want to divide by 4, so I get r equals a negative 1. And for this one, I am going to go ahead and check it. And the reason why is because the notes that I'm looking at actually don't have the answer to this one. So I want to make sure that we did actually get that correct. Okay, so 5 minus the r is negative 1 plus an 8 times that negative 1. Does that equal 3 with a negative 1 plus 1? So 5 minus a negative 1 would be plus 1. 8 times negative 1 would be a minus 8. Does that equal negative 3 plus 1? So 5 plus 1 is 6. Minus 8 is negative 2. And negative 3 plus 1 is also negative 2. So we did it right. So just say, like what if? What if we thought that the answer was r equals 1? Here's what would happen if we went to go and check it. just so you can see what a bad check looks like. So 5 minus, that would be a positive one now, 8 and 1, 3 and 1, plus 1. So I'd have 5 minus 1 would give me 4, plus that 8, I would get 12, equals a 3 plus 1 is 4. That doesn't work. Sometimes I've seen students that go and they check it and they see this and they get confused and they think that's the whole like inconsistent thing. It's not. That's only when you are given the initial problem and then you get that two things don't equal out. When you check it and that happens, that means that you made a mistake. So what you'd want to do is go back to your work and check your work, and your check should work out. Okay, so that should always be that the number equals the number. So like the -2 equals -2. All right, hopefully that makes sense. And that wraps up today. I hope you have a wonderful day.